The topic of this video is graphing piecewise defined functions. Let's look at a problem. F of x equals negative 3x plus 5 if 0 is less than x is less than 1, 2 if x equals 1, 3x minus 1 if x is greater than 1. All right, so let's go through the steps. There are 4 steps of graphing a piecewise defined function, and the first step is to identify which pieces are equalities and which pieces are inequalities. Remember, an equality looks like this: x equals number. That means that this middle piece is going to generate just a single closed dot on our graph. But these others don't look like that, therefore they are inequalities, and those are graphs we're going to have to create the entire graph of and then cut them and keep the relevant pieces. Okay, great. So now that we know which pieces we have to deal with and in which manner, we're ready to begin. The cutting pieces are steps 1 and 2 of the solution. The single dot piece is step 3 of the solution, and step 4 is where we put the finishing touches on our graph. Okay, so let's start with our top piece. F of x equals negative 3x plus 5. Hopefully you recognize this is a line in slope-intercept form. Now, f of x is the same thing as y. The slope is negative 3 and can be written as negative 3 over 1, and then we have the rest. From this, we can see the y-intercept is 5. So when we want to graph this line, we plot a single dot on the y-axis at 5. The slope, which represents rise over run, is negative 3 over 1. So we start at the y-intercept, then rise negative 3 and run 1. That's 3 down and 1 to the right. So 1, 2, 3 down and 1 to the right, and we put a point. 1, 2, 3 down and 1 to the right, and we put a point. And we do this until we run out of room. So it looks like I've almost run out of room. I might be able to get one more point in here. So we go down 1, 2, 3, and then 1 to the right, and we put a point. After you run out of room in one direction, go back and go the other direction. So what's the opposite of 3 down, 1 right? 3 up and 1 to the left. All right, so now we can get out our straight edge and connect all of these dots together. Remember, lines, line segments, and rays must be drawn with a straight edge. So everybody get out your straight edge and connect these dots together. Okay, great. So we've created our entire graph of the first piece. Now we have to cut it. To figure out where we cut it, we look after the word if, and we look for any numbers. Any numbers that we see are places where we have to cut. So we're going to have to cut this graph at 0 and 1. So find 0 and 1 on the x number line and cut vertically at those locations. So that means going right through this point that has an x coordinate of 0, and right through this point, which has an x coordinate of 1. So as you can see, these two cut lines are very close together. Now, we have to decide what part of this we're going to keep and what part we're going to throw away. The x is in between the 0 and 1, and therefore we're only going to keep the part of the blue line that is in between our two cut lines. So all of this goes away. Gone. All of this goes away. Gone. And the only thing I'm left with is this little line segment going from here to here. Now, I am required to put open or closed dots where the curve meets the cut, where the blue curve meets the the red cut. So let's take a look at what kind of symbols we'll use. The 0 is associated with the less than symbol. That's an open dot. The 1 is associated with the less than symbol. That's also an open dot. So wherever the curve meets the cut, we need an open dot. So that would be here, an open dot at coordinates 0, 5, and here, an open dot at coordinates 1, 2. Okay, great. We're done with our first piece. The top line is done. Now we're going to move to the bottom line. The bottom line is f of x equals 3x minus 1. This is also a line in slope-intercept form. Y equals 3 over 1, and then the rest of the equation. We will use the same approach. First, plot the y-intercept of -1. Here it is. Next, use the slope to rise and run to find other points on the line. So, starting at the y-intercept and counting the number of times you move, go up 3, 1, 2, 3, and then 1 to the right. We end up at coordinates 1, 2. Repeat this until you run out of room. 1, 2, 3, and 1 to the right. Looks like I can get one more dot in here if I give myself just a little more tick marks on the y-axis. 1, 2, 3, and 1 to the right. All right, now get out your straight edge and connect all of these dots to form your line. Remember, lines, line segments, and rays should be drawn with a straight edge, always. Okay, great, we've got our line. Now we've got to figure out where do we cut it. So we look at the numbers after the word if, and we find that there's only one. 1. So 1 on the x number line is where we are going to cut. Right here, 1. And we're cutting vertically, so it's going to go right through this point, which has coordinates 1, 2. All right, so we've cut our line. Which part do we keep? Well, we keep the part where x is greater than 1. Where is x greater? To the right. So that means that we're going to erase all the parts of the blue line that are left of the red dashed line, because we only want the parts that are to the right, greater than 1. Okay, great. So now we just have to put an open or closed dot where the curve meets the cut. In this particular instance, the 1 is next to a greater than sign, so it's an open dot. So where the blue curve meets the red cut, we have to have an open dot. And we need an arrow here. All right, so these are the two pieces that we're now going to paste together to form our final picture. Let's take a look at what we know. We know that we have a line segment that goes from 0, 5 to 1, 2. So let's draw that. 0, 5 to 1, 2, a line segment. Straight edge for line segment. Next, we know that we have an open dot at 1, 2. Oh, interesting, we've already got one here. When two open dots are in the same place, you get a single open dot. And a ray going up and away through the point 2, 5. So once again, I will get out my straight edge since this is a ray through the point 2, 5. All right, that takes care of the top and bottom pieces. We still have to deal with the middle, but luckily the middle is the easy one. The middle one says f of x equals 2 if x equals 1, the middle line. So f of x is the same as y, so we get y equals 2, x equals 1. And when you write that as an ordered pair, you get the ordered pair 1, 2. So it seems like that point is showing up a lot in this problem. 1, 2, 1, 2. And now we're going to put a closed dot, because it says equals, at 1, 2. So what happens if you have a closed dot and an open dot in the same location? The closed dot fills the open dot. And with that, we are done creating the graph of this piecewise defined function.